Guys, welcome to another episode of CUDA Education. Today, I want to quickly go over the prepare corner pipeline function. Now, We are on our journey to basically. We are on our journey to basically create a new graphics pipeline with some particles moving in the corner. So this is the default application here. And we want to create a new set of particles in the corner, independent of these particles that are moving, randomly, right? We're going to do it with a new graphics pipeline and sort of, yeah, just have those particles in the corner here moving, right? Just so that we go through the process of creating new particles and seeing them move, right? The reason why I make them move is because I also want to get our hands dirty with the compute side of things. So if I just wanted to present particles to the screen that's not moving, it would be a lot simpler and we wouldn't learn anything. But because we want them to move, we have to do a lot more work. Now, the particles that I have over here are not going to be as special and as aesthetically pleasing as this, okay? But, the purpose of it is just to learn and understand what's going on. Okay, so we are continuing our journey. We are basically, we are right here, prepare corner pipeline, right? So this is our journey. On the left is your default application. On the right is the new application with changes, right? So the yellow basically signifies changes, right? And in the bigger scheme of things, we are right here, okay? So let us just go through quickly what it is that we are doing. Now, I'm not going to show you the end result until the very last video, right? Create a pipeline layout with no descriptor sets, right? That's going to be very important. We're not having descriptor sets. Remember, we have our vertex buffer fetch, which is the memory that we've been working on. We set up the buffer that the compute and the graphics will be able to have access to, so we don't need descriptor sets. We have input assembly. Thing to note here is that we're using points, so it's the particles are points. Rasterization stuff, you guys can look up in the spec these what these flags mean. Blends, attachment, color blend, depth stencil. The depth stencil is off. Remember, depth stencil and depth test basically deals with if one particle is in front of another. You have to be aware of that so you don't spend resources rendering things that are not visible and all that stuff. But we're just dealing with simple stuff and we're turning all that stuff off. Viewport is just basically the window the application runs, right? Multi-sample stuff, dynamic state stuff. We'll get into that at some time in the future. The binding is very important. How are we binding the data? Um, the binding is zero. Binding zero. We are striding vec4. So the size of the variable that we're reading is vec4. So we have to stride vec4 for each variable. And then how do we interpret that data? Vertex input rate vertex, right? So that's how we interpret the data. Then we get to the attribute stuff, binding, location, the format of the data. So this is, I think, it's more like color and stuff. And what's the last thing? And the offset, right? So yeah, if we have this binding, location, format, and offset. For the binding description, we had binding, stride, and input rate, right? Binding, stride, and input rate. So this is binding, location, format, and offset. Okay. Then we have the vertex input state, which we're just encapsulating everything together. We have to attach our shaders. Now notice that the binding and location, we are basically calling the shader files, the spare v files, right? So we have location 0, location 0. If we don't declare a binding, the binding is assumed to be zero. That's just a GLSL thing. If we don't declare a binding, we automatically assume it to be zero. And we have right, we have our shaders here that we associate with the pipeline that we're running. This is all a pipeline that we're preparing, right? Notice that for the vertex shader dot vert, um, we have our flag VK shader stage vertex bit, and then for our fragment shader, VK stage fragment bit, right? So that's color and stuff, right? My particles aren't going to be as special as what you saw with the default application. I'll just tell you that right now. It's going to be very simple stuff, but because we're not trying to add complexity to this thing. It's already involved, right? So we have our graphics pipeline. We create we set up everything for our graphics pipeline. We encapsulate all of our options. Um, and we have additional blend stuff for you creatives. This is where you live. The blending is very important, so things look good or don't look good, or look nice and don't look nice, or pop or don't pop, all of that stuff, the blending. And then we create our graphics pipeline. Okay, and we create our graphics pipeline, and we encapsulate all of these things that we encapsulate all these things that we set up right here. Now if we go back to our notes, we're just going to basically go through this again. Draw a set of points, the corner pipeline, from a vertex buffer into the same render pass as the main scene. So I'm going to talk about this, and then I want to talk about this briefly. In the same render pass as the main scene. So vertex buffer. We spent a lot of time with vertex buffer in the previous episode in this series. Create a vertex buffer for corner particles, right? So all of this stuff, the compute is, the purpose of the compute is this memory. What it's going to go in and read and write, update positions and velocities. So again, the particles are moving, right? And that's why the compute comes in, because we don't just have stationary particles. The particles are moving and there's velocity, so we have to update that with the compute stuff, which is why I made the particles moving. And then the graphic stuff is presentation to the screen. Okay, so we talked a lot about that, right? Um, so draw a set of particles from a vertex buffer, right, into the same render pass as the screen. Now this is something that you know we're gonna have to investigate. We're gonna have to investigate. We're gonna have to investigate. We're gonna have to investigate at a later time. Basically, the render pass is the presentation to the screen, and we have to basically attach our small moving particles in the corner to the main presentation to the screen, right? So there's a process for doing that in terms of pipeline creation and how we set up stuff and the variables. So we'll get into that at some point. First thing to note is that there are no descriptor sets are needed. Okay, no descriptor sets are needed. This was a big gotcha for me, because normally when you're setting up pipelines and you want to access data and stuff, you need a descriptor set. But we don't need that here because we have our vertex input state. So descriptor sets are needed only when shaders need to access external GPU resources via descriptors, uniform buffers, stage storage buffers, sampled images, etc. This corner pipeline can draw purely from fixed function state plus vertex buffer inputs. So vertex positions, point size, fragment shader. So this is our vertex fetch, right? The vertex buffer kind of stuff. So we actually access the data here and not use the descriptor set. So that's a big time savings. Um, but I didn't. I mean, I knew sort of independently, but I didn't put it all together. That so in Vulkan there are two binding systems. There's a vertex input bindings, which is all of this stuff, and then there's a descriptor bindings, which is all of this stuff, right? And yeah, so the vertex, the descriptor bindings and all that stuff, right? And then we describe the pipeline. So we have our pipeline layout, input assembly, right? We talked about the input assembly. That was this guy right here. So we know that it's points that we're dealing with, We're dealing with points, rasterization, color blending, depth stencil. We turned all that stuff off. Using one viewpoint and one scissors, multi-sampling, vertex input buffer, how bytes in the vertex buffer map to shader inputs, binding description, and attribute description. So that was this guy here where we were talking about the binding and the attribute description. Vertex input, one binding, one attribute at offset 0 in vec4, right? So that's this guy there. And then shader stage is all of these guys here. And we attach it to the pipeline. Pipeline creative additive blending create actual pipeline. What this pipeline is intended to achieve: no textures, no descriptor sets, no depth tests, optional additive blending. Uses only a vertex buffer of positions. Okay, so that's pretty much it for this particular function. Again, guys, in the big picture stuff, we are here, right? We're gonna need to do 2 or 3 extra videos just to clear up everything else. A lot of it is just settings and stuff, right? We're updating settings because we're modifying code, right? So we have to update things. We also have to call new things, right? We're gonna have to bind. We're gonna have to bind some stuff, and we're gonna have to submit some stuff, right? And we also have to deal with synchronization because now, even though I try to do everything as independent as possible, we are we are presenting to the same screen and we are using the same GPU. So there's an extra flag that we have to take care of. We have to add for our wait mask, wait stage mask, destination stage mask, and then also for the semaphore stuff. So here we had 2 semaphores we're waiting on. Now we're waiting on 3 semaphores. Is GPU synchronization. So 2 GPU processes. We have to make sure that they don't step on each other's toes. So that's why we go from wait semaphore 2 to wait semaphore 3. We update the wait semaphore count from 2 to 3, obviously, and all that stuff. But we'll get into that later. Guys, you know the deal. If you want to join in on this stuff, tutorial number 1 is installing the Vulkan SDK on your Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is installing all of the examples that we have here, including this one. Now, you know, most of these stuff is not ray tracing, but if you want the ray tracing stuff, you also have to make sure your GPU is ray tracing capable. Learn Vulkan in 2026. Time is expensive. Don't waste time. Do what you got to do. Be in a better place at the end of come December than you are in February of 2026. Play video games, but also learn how to build video games and computer graphics. It's the future. It's not going anywhere. If you know anyone that's creatively inclined, please, please, please encourage them to start the journey with you to learn Vulkan and get stuff going with this stuff. Thank you guys for watching. Have a great day. This is Kuda Education. Like, subscribe. You know the deal.